Right, looks like we're going to do Algebra 2, Lecture 12.7 and 12.8 today. That's OAS A2N14. The student will write expressions that have rational exponents. A rational exponent is just it's an exponent, and the word rational means the exponent is going to be a fraction. Okay, so our fractions are going to be in the exponent. We have fractional or rational exponents, and we're going to rewrite those as radical expressions. That's an expression that has like a square root symbol. So student will take an expression that has a rational exponent and rewrite it as a radical expression, and vice versa. So we're going to go from radical expressions to rational exponents, and from rational exponents to radical expressions. I'm going to show you how to do that. Here we go. Here's the basic idea right here. If we have something that's raised to a rational exponent, that's a fractional exponent, we can rewrite that as a radical by sliding the denominator out this way and dropping this numerator down like this, and then putting a little radical in there. So this has the exact same value as this. And if you were given this and said write it as a rational exponent, you would just get rid of the radical symbol, slide the m up and slide the n under. So you can go from here to here or from here to here. That's mechanically what you're doing. They have the same value. If you look at this one here, this expression is equal to x over x to the m minus n, and this expression is also equal to x to the m minus n. So these two have to equal each other. This and this are just two ways of saying the same thing. When I do today's examples, I'm going to do both of these. I believe in today's worksheet, the multiple choice, the answers are going to be written in this form, but you'll often see them written in this form, so I'm going to write both of them. Okay? This just says the same thing. If you want to write this as a radical, the n slides out, it becomes what we call the index, and the m drops down, but instead of being under here, like it is here, we put parentheses and stick it out here. So that's what I'm keeping in mind as I do these. Hopefully it'll make sense. Write each expression is in radical form. So what I want to do is I want to slide this 2 out and drop this 1 down. Okay. Now let's take a little look at this real quick. This is the square root. Now normally, when we have a square root, we don't show this index 2. This is the only place I can think of where you're going to actually have an implied 2 is in the square root. If you can't see this index, it's an implied 2. It's the square root. So what I'm going to do is rewrite this with the 2 not being shown because you don't have to. And anything that's raised to the first power is that thing. Anything raised to the first power is itself. So I'm not even going to bother showing this 1 or these parentheses. I can just say 5m under the radical. So this is the square root of 5m. I didn't need to rewrite this with a parenthesis because anything to the first power is itself. So these two are both implied. Anything to the 1 power, you don't have to show the 1 power. The square root, you don't have to show what we call the index of the radical. Okay? If it's anything but a 2, if it's a cubed root or a 4th root or anything like that, we need to show the index. But the square root, if you don't see the index, it's an implied 2. So this is equal to this. That's what you would look for among your choices. Let's take a look at this one. This is the square root. I'm going to bring this out here of p to the 5th power. Okay. Now, in keeping with this idea here, that this and this are the same thing, I'm going to say or. I'm also going to say I don't need this index. I don't need to show it because it's implied. So I'm going to say this could be the square root of p to the 5th or the square root of p, and put parentheses around it and put that power out here like we did here. This and this have the same value. I'm going to show it both ways. This is how I've run into it in a lot of tests. On today's worksheet, they're going to be writing it like this. So it's good to know that they have the exact same value. They're the exact same. Two different ways of saying the same thing. Okay. And as I said, I believe today it'll be written like this. Let's take a look at another one. And here, again, the index 2 disappeared. It didn't disappear, but it's implied. All right, let's take a look at this one. We're going to rewrite this as a radical. That's one way of doing it. And this is not implied, the 5 isn't implied, so I'm going to leave it there. And the 7 is it's going to apply to both of these factors. That's 10 times v. So you could think of this as 10 to the 7th times v to the 7th. But today, we're just going to write it either like this or like this. And as I said, this whole thing is being raised to the 7th power has the exact same value as this. And I believe that today's worksheet, your answers will be written in this form. Okay? So the 5 slid out, the 7 dropped down, and we put parentheses around it. Instead of having parentheses in here, we just move the parentheses out, scoot the 7 up. Okay, let's do another. The 6 comes out as the index of the radical, the 6th root of 10r to the 7th. And then we can rewrite it like this also. Okay. Now, there are ways we could simplify this even further, but for now, for today, we're just going to rewrite rational exponents as radicals. And we'll get into simplifying them later. Okay? First things first. So we've had expressions that were given to us as a rational exponent, and we rewrote them as radicals. Rational exponent, that means a fractional exponent, rewritten as radicals. Okay? And the objective said we're going to do that, and vice versa. So we're going to go from these radicals, and we're going to write it in exponential form. We're going to have something raised to some power. So what I'm going to do here is I'm going to say, okay, I'm going to get rid of this radical, so I'm going to have 7x in parentheses. Got rid of the radical. And the 2 goes up and the 3 slides under it. Dun, 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 dun. Just that simple. Just another way of saying the same thing. This is a rational exponent. That's the exponent. It's 2/3. Rational means a fraction. And this is a radical form. So we went from radical to rational exponent. Up above, we were going from rational exponent to a radical. Okay, let's take a look at this one. Now remember, when I look at this, I want to keep in mind that there's an implied 2 right here. The index of this radical is a 2. So when I go to rewrite this, I get rid of the parentheses and the radical. And the 3 goes up. I don't need the parentheses in this case. And the 2 slides under. So r to the 3/2 is equal to the square root of r cubed. Just another way of saying the same thing. Let's take a look at this one. Now here's one that has 2 implied values. This index is an implied 2, the square root. There's always a 2 here. You can't see it, but it's there. It's implied, the square root. And there's always a 1 for any number or value, any variable or number raised to the first power is itself. So there's an implied 1 as an exponent there. Now to write this as a rational exponent, I get rid of the radical, raise the 1 up, slide the 2 under. Okay. And in the same, keeping in the same mode of thought here, I see there's an implied 2 right there. So I'm going to get rid of the radical and the parentheses. 7v, well not the parentheses, the parentheses, this whole thing is going to be raised to the 3/2 power. So I misspoke when I said get rid of the parentheses. We need those parentheses. Okay. So what I did was I raised the 3 up, slid the 2 under it. the factors, both of them, are being raised to the 3/2 power. So there we go. That's what we're doing today. The student will write expressions that have rational exponents as radicals. That's what we did here. Rational exponents, we wrote them as radicals. Rational exponent, fractional exponent, rewritten as radicals. And again, remember that these two mean the same thing, and I believe today's are going to look like this. And then we wrote vice versa, radical expressions rewritten as rational exponents. So we were given radical expressions. That's an expression that has a square root or a cubed root, the radical symbol, and we rewrote it as a rational exponent. Rational means fractional. So that's what we did. That's what the worksheet will be doing, asking you to do. You can do this.